Hello students, welcome to Anne's classes. Let's do chapter 1 number system exercise 1A. So we are doing exercise 1A and we are now with question 8. Write the successor of each of the following. Successor of a number means the number that comes after a number. So all we have to do is add 1 to the number given and we will find the successor. So here to find the successor of 6001, we just have to say that will be 6001 plus 1. We just add 1 to it and that is 6002. Let's go to the next one. We have 1099. So that will be 1099 plus 1. Now we can add it up and see. 1099 plus 1. 9 plus 1 is 10, carry 1. 9 plus 1 is 10, carry 1. We have 1 here and 1. 1100 is the successor. 1100. The next number is 12,749. So that will be 12,749 plus 1. So 749 plus 1 is 750. 12,750. Now if you have a doubt, you can add it up this way. Okay. Next one is 2,19,708. So that is 2,19,708 plus 1. So we just have to look at the ones period. 708 plus 1 makes it 709. So this is equal to 2,19,709. The next number is 62,399. So 62,399 plus 1. So look again at the ones period. 399 plus 1 will make it 400. So that is 62,400. So whenever you have a doubt, all you have to do is write it out like this, add 1 and get your answer. Question 9. Write the predecessor of each of the following. So predecessor is the number that comes before. So to find the number before, we have to subtract 1 from the given number. So here we have 99. So 99 minus 1 gives us the predecessor and that is 98. That's simple, isn't it? The next number is 1305. 1305 minus 1. Again, look at the ones period. 305 minus 1 will make it 304. So this is equal to 1304. Now the next number is 32,000. So 32,000 minus 1. Sometimes when the numbers end in zeros, it's difficult to find the predecessor. So you can do the actual subtraction and see. So here let's do 32,000 minus 1. So here let's do the subtraction. So 0 as you can see is smaller. So we borrow from here. So this is 1. 10 becomes 9. Again 10 becomes 9 and this is 10. Now let's do the subtraction. 10 minus 1 is 9. Then we have 9, 9, 1 and 3. So this is 31,999. So 31,999 is the predecessor of 32,000. Similarly, the next number is 1,65,000. It's ending in zeros. So we can do the same thing. So let's do that. 1,65,000 minus 1 will give us the predecessor. So let's take 1,65,000 and subtract 1 from this. Again, we need to borrow from 5. So 5 becomes 4, 10, 9. Again, 10 and 9. And this is 10. Now, 10 minus 1 is 9. Then 9, 9. Then we have 4, 6 and 1. 1,64,999. 1,64,999 is the predecessor of 1,65,000. Next question, write the whole number whose successor is this number. So here we are not asked what the successor is. Instead, we are saying this is the successor of a number. We need to find that number. So to find the required number, this is what we have to do. We have to find the predecessor of this number. I hope you understood. Here the question is, write the whole number whose successor is 100. So 100 is a successor. So to find the number whose successor is this, we have to find the predecessor of this number. So predecessor of 100, which is 100 minus 1. 100 minus 1 is 99. So 100 is the successor of 99. Similarly, now here we have to find the whole number. The successor is 6299. So what is that number? So the required number again is the predecessor of 6299. So let's do that. 6299 minus 1. And again look at the ones period, 299. The number before that will be 298. So 6298 is the number whose successor is 6299. Next number. Find the number whose successor is 71,650. So the required number will be the predecessor of this number. So that is predecessor of 71,650. So that means we need to subtract 71,650 minus 1. You can do the actual subtraction, or you just have to look at the ones period. The ones period is 650. What is the number that comes before 650? 649. So a number will be 71,649. Now if you have a doubt, you can do the actual subtraction. You can take that number 71,650 and minus 1 from this, and you will get your answer as 71,649. So if you can think and do, you can straight away write your answer. If you find that difficult, you can do the actual subtraction. Next question, write the whole number whose successor is 42,000. So the required number is the predecessor of 42,000. So the predecessor of 42,000 means 42,000 minus 1. Now here we can do the actual subtraction so that we don't make a mistake. Minus 1. Now borrow from 2. 2 becomes 1. 10, 9, 10, 9 and 10. Now 10 minus 1 is 9. Then we have 9, 9, 1 and 4. So what is our answer? 41,999. Let's write it here. 41,999. This is the number whose successor is 42,000. Question 11. Write the whole number whose predecessor. This time we have to find the number whose predecessor. This is the predecessor of a number. Which number is that? In this case, we have to find the successor. So when you're asked to find, when you have a question like this where you have to find the whole number whose predecessor is given to you, you have to find the successor of that number. Okay, so what is the successor of 1,000? Successor means we add 1 to the given number. 1,000 plus 1. This is easy. 1,000 plus 1 is 1,001. So the next number, we have to find the whole number whose predecessor is given to us. The predecessor is given to us. What is that number? So again, we have to find the successor of this number. The required number is successor of 3,189, and that is 3,189 plus 1. Again, instead of actually adding it, just look at the ones period. The ones period is 189. And what is the number that comes after that? 190. So this will be 3,190. This is our answer. Next question, write the whole number whose predecessor is 3001. This is the predecessor. Okay, so we have to find the successor. That will be the answer. So the successor of 3001 is 3001 plus 1. So look, 3001, look at the ones period. We only have 1. What is the number that comes after 1? 2. So 3001 plus 1 is 3002. Next question, we have 8,000. This is the predecessor. So which is a number whose predecessor is 8,000. We have to find the successor of 8,000. So the successor of 8,000 means 8,000 plus 1. 8,000 plus 1 is 8,001. This is easy, isn't it? 8,001. Next one, we have 9,999. This is the predecessor of a number. So which number is that? That number will be the successor of 9,999. So that is adding 1 to this number. So let's do the actual addition. 9,999 plus 1. 9 plus 1 is 10. We carry 1. 9 plus 1, 10. Carry 1. 9 plus 1, 10. Carry 1. 9 plus 1, 10. So 10,000. So the number 10,000 will give us the predecessor 9,999. So this is how you answer a question like this. Question 12. Write down 3 consecutive whole numbers succeeding 72,597. Consecutive means numbers that come one after the other without skipping any number in between. So 3 numbers that come after 72,597. Succeeding means coming after this number. So to write 3 consecutive numbers succeeding 72,597, we just have to keep adding 1. So let's take the first number. So here we have 72,597 plus 1. What do we get? 7 plus 1 is 8. So we've got 72,598. That's the first number, 598. To take the next number, again add 1 to it. 8 plus 1 is 9. 9. The rest are the same. 72,599. So that is our next number, 72,599. Then to find one more number, we add 1 to it. 9 plus 1 is 10. Carry 1. 9 plus 1 is 10, carry 1. 5 plus 1 is 6. Then here we have 72. So the third number is 72,600. So we have got our answer. The 3 consecutive whole numbers succeeding 72,597 are 72,598, 72,599, 72,600. Question 13. Write down 3 consecutive whole numbers preceding 5,10,001. So again, we have to get 3 numbers that come one after the other. Now they should all be numbers that come before this number. So 3 consecutive whole numbers preceding 5,10,001. To find the predecessor, we have to subtract. So 5,10,001. Subtract 1 from it, you get the predecessor of this number. So 0, we have zeros everywhere, the rest remains the same. 5,10,000 is the first number. So let's write that. 5,10,000 is the first number. Now we need to get 3 more numbers. So take this number and again subtract 1 from it. So this time we will have to borrow. So let's borrow from 1 here. So when you borrow from 1, 1 becomes 0. So this is 10, 9, 9, 9 and 10. Now subtract. 10 minus 1 is 9. Then we have 9 and 9. Then again 9. We have a 0 here and 5. So this is the predecessor of 5,10,000. And what is it? 5,09,999. So let's write our answer, 5,09,999. Now we need to get one more number. So we need to subtract 1 from this number. So 9 minus 1 is 8. Then we have 9, 9, 9, 0 and 5. So what is the number? 5,09,998. That's our third number. So 5,09,998. So we have found 3 consecutive whole numbers preceding 5,10,001. What are those? 5,10,000, 5,09,999, 5,09,998. How many 6-digit numbers are there in all? Totally, how many 6-digit numbers are there? To find it, there's an easy method. First, write down the largest 6-digit number. Largest 6-digit number will all be nines. There'll be 6 nines. So we have the largest 6-digit number. Let's put down 6 nines. 9, 4 more, and then let's put commas to read this. So what is this number? 9,99,999. This is the largest 6-digit number. Then we should write the largest 5-digit number. So the largest 5-digit number will have 5 nines. So 99,999. So what did we do? We wrote the largest 6-digit number and the largest 5-digit number. Now to find how many 6-digit numbers are there, we have to just subtract these two. So let's subtract and see. So when we subtract, what do we get? 0, 0, 0, and again we have 0, 0, and we have 9. That means the total number of 6-digit numbers is 9 lakh. There are 9 lakh 6-digit numbers. Next question, write the largest 8-digit number. So the largest 8-digit number will have 8 nines. So let's write that. So 1, 2, 3, 4, 5, 6, 7, 8. Now place your commas. So when you place, you say ones, tens, hundreds. The ones period and then a comma. Then we say 1,000, 10,000, a comma here. Then we say lakh, 10 lakh and a comma and crores. Now to read this number, to make it easier, we'll write the period above. 9 crore 99 lakh 99,999. So this is the largest 8-digit number. Question 2 is write the smallest 8-digit number. The smallest 8-digit number will be 1 followed by 7 zeros. So 1, 2, 3, 4, 5, 6, 7, and this is 1 crore. So we have the largest 8-digit number and the smallest 8-digit number. Question 16. Write all possible 2-digit numbers formed by the digits 3, 7 and 9 when repetition of digits is not allowed. So we have to use these 3 digits. So the given digits are 3, 7 and 9. Let's write that down. 3, 7 and 9, and we are going to form 2-digit numbers using these digits 3, 7 and 9, but remember we cannot repeat any digit. So the easiest way to do is start with 3. Okay, so let's start with 3 and form 2-digit numbers. So take 3 and 7, 37. Again use 3, so it is 3 and 9, 39. Now we can't use 3 anymore, so now we'll take 7. 7 and 3, 7 and 9. So that is 73 and 79. We can't use 7 anymore. Let's take 9. 93, 97. So we can say 93 and 97. So we have formed all possible 2-digit numbers using this. Easiest way is to start with the number given to you and add the other numbers and go along like we did here. So the required numbers are 37, 39, 73, 79, 93 and 97. Question 17, the first one, write all possible 3-digit numbers that can be formed by the digits 1, 3 and 7 using each digit only once in each number. That means you cannot repeat it. So what are the given digits? They are 1, 3 and 7, and we have to form 3-digit numbers using these things. So again, let's start with 1. Okay, let's start with 1. 1 is given and the first number is 1. To form a 3-digit number, take the other two numbers. So 137. Again start with 1. This time interchange 73. So we've got 173. You can't use 1 anymore. Now let's go to the next number, that is 3. Start with 3 this time. So 371. Then we can say 317. We can't use 3 anymore. Let's go to 7. So that will be 713. Then we can say 731. That's it. We can't use the numbers anymore. So let's write down the required number. The required numbers we just found out are 137, 173, 371, 317, 713, 731. The next question, write all possible three-digit numbers that can be formed by these digits 9, 2 and 0 using each digit only once in each number. So let's begin. What are the digits given to us? 9, 2 and 0. So all possible three-digit numbers formed by these three digits. Let's begin with 9. So when you begin with 9, we can say 920. Then we can put 0 in the middle, 902. Now let's take 2. 290. Again 0 in the middle, 209. Now the next thing is to take the third digit, isn't it? But the third digit is 0. You can't start a number with 0. You will only get two-digit numbers. So this time we get only 4 numbers. So the required numbers are 920, 902, 290 and 209. Write the smallest four-digit number that can be formed by the digits 0, 1, 3 and 6 using each digit only once. So what are the given digits? The given digits are 0, 1, 3 and 6, and we have to make the smallest four-digit number using this. So whenever we make the smallest number, we arrange from small to big or ascending order. So which is the smallest number here? The smallest digit is 0, but we cannot start with 0. So we go to the next smallest digit, which is 1. So 1, and now we put the 0 and go in ascending order, which is the next number, smallest number, 3 and 6. So this is the smallest number that can be formed using the digits 0, 1, 3 and 6. So this is our answer, 1036. This time we have to write the greatest four-digit number using these digits given to us only once. So what are the digits given to us? 0, 2, 7 and 5, and we have to make the greatest four-digit number using this. So when we write the greatest, we start from big to small, or we arrange the digits in descending order. So the biggest is 7, then 5, then 2 and 0. So let's write the number 7, 5, 2 and 0. When you put a comma, the number is 7520. Question 19. Write the smallest four-digit number of 4 different digits. Now this point is very important, so you must read your question completely. So smallest four-digit number. If you simply take the smallest four-digit number, it is 1000. But here the question says clearly the digits should all be different. That means I cannot have 3 zeros here. I can have 1 0, but I cannot have 3 zeros because the digits have to be different. So in this case, I can write 1 as it is and then 0. Now to form the smallest number, we go in ascending order, small to big. So we have 0, we have 1, the next number will be 2 and then 3. So now can you see this is 1023 and all 4 digits are different. So what is our answer? Our answer, the smallest 4-digit number of 4 different digits is 1023. This is our answer. Question 20. Write the greatest 4-digit number of again 4 different digits. Now the greatest 4-digit number is 9999. But as you can see, the digits are all the same, isn't it? Now here it says all digits should be different. So what we can do is leave the first digit as it is, and instead of these 3 nines, we're going to write numbers in descending order after 9. So that becomes 9, 8, 7 and 6. So that is 9876. So the greatest 4-digit number of 4 different digits is 9876. So with this, children, we come to the end of our exercise. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.